Hey everyone, today we are going to solve the Daily LeetCode challenge of 28th March 2024 and the problem statement is length of longest subarray with at most k frequency. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array num such that it contains only positive integers and we have been given an integer variable k. And what we have to do is we have to find the length of the longest subarray such that each of the elements in that subarray has a frequency of either less than or equal to this k. Okay. Now let's first understand what is a subarray. So a subarray is a contiguous part of an array. Okay. Now if I'll ask that, is this 2, 3 a subarray? So you'll say that yes, this 2, 3 is a subarray. Why? Because it's continuous, right? We are not missing any elements in between. Now if I'll ask that, is this 2, 1 a subarray? So you'll say that this 2 and this 1 is not a subarray. Why? Because it's not a continuous part of this nums, right? We are missing an element in between. So it's not a subarray. Now let's find out that what is the length of the longest subarray for this given example. But before that, let us first write down all the possible subarrays of this nums. Okay, so we will have this 1, then we'll have this 1, 2, then we'll have this 1, 2, 3, then we'll have 1, 2, 3, 3, and we'll have 1, 2, 3, 3, 2, then we'll have 1, 2, 3, 3, double 2, then we'll have 1, 2, double 3, double 2, 1, then we'll have 1, 2, double 3, double 2, double 1, then we'll have 1, 2, double 3, double 2, double 1, 3. Then we'll have 1, 2, double 3, double 2, double 1, 3, 1. Now we will have 2. We'll have 2, 3. We'll have 2, double 3. Then we'll have 2, double 3, 2. Then we'll have 2, double 3, double 2. Then we'll have 2, double 3, double 2, 1. Then we'll have 2, double 3, double 2, double 1. Then we'll have 2, double 3, double 2, double 1, 3. Then we'll have 2, double 3, double 2, double 1, 3, 1. Now we will have 3. We'll have double 3. We'll have double 3, 2. We'll have double 3, double 2. We'll have double 3, double 2, 1. We'll have double 3, double 2, double 1. Then we'll have double 3, double 2, double 1, 3. Then we'll have double 3, double 2, double 1, 3, 1. Now we will have this 3, 3, 2, 3, double 2, 3, double 2, 1, 3, double 2, 1, 1. Then we'll have 3, double 2, double 1, 3. Then we'll have 3, double 2, double 1, 3, 1. Now we'll have this 2. We'll have this double 2. We'll have this double 2, 1. Then we'll have double 2, double 1. Then we'll have double 2, double 1, 3. Then we'll have double 2, double 1, 3, 1. Now we will have this 2. Then we'll have this 2, 1. Then we'll have this 2, double 1. Then we'll have this 2, double 1, 3. Then we'll have this 2, double 1, 3, 1. Now we will have this 1. Then we'll have double 1. Then we'll have double 1, 3. Then we'll have double 1, 3, 1. Now we'll have this 1. Then we'll have this 1, 3. Then we'll have this 1, 3, 1. After that, we'll have this 3. Then we'll have this 3, 1. Then we'll have this 1 at the end. Okay. So these are all the possible subarrays of this nums. Correct. Now let us remove all the invalid subarrays. Now what do I mean by invalid subarray? So we will call a subarray invalid if in that subarray frequency of any element, say for example, this represents frequency of any element. So if frequency of any element is greater than k, in that case, we will call that subarray is invalid. Why? It's because we want to find out the length of that subarray that has at most k frequency. Now, what does at most k means? At most k means either less than or equal to k frequency, right? So, which one subarray will be invalid? In the subarray in which the frequency of any element will be greater than k, then we'll say that that particular subarray is invalid. So, let us remove all the invalid subarrays from this. So, we can see that this one is valid because in this we have only one that has a frequency of less than equal to 2. This subarray is also valid. This subarray is valid. This subarray is valid. This subarray is valid. This subarray is invalid. Why? Because we can see that in this subarray, there is 2 that has a frequency of 3, right? This 2 element is occurring 3 times. And what do we want? We want all the elements to occur either less than 2 or equal to 2, right? So this is an invalid subarray. Similarly, this is invalid, this is invalid, this is invalid, and this is also invalid subarray. Now here we can see that this is valid, this is valid, this is valid, this is valid. Now this is again an invalid subarray. Why? Because we can see that 2 is occurring 3 times. So this is invalid, this is invalid, this is invalid, this one and this one is also invalid. Now here we can see this is the valid subarray, valid subarray, valid subarray, valid subarray, valid subarray. This is also valid. Now we can see that this is an invalid subarray. Why? Here the frequency of 3 is 3, right? And what did we wanted? We wanted only less than or equal to 2 frequency. So this is an invalid subarray. This is also an invalid subarray. Now this is a valid subarray, valid, 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 valid subarray, and this one is an invalid subarray. Why? In this subarray, 1 is occurring 3 times, right? So this is an invalid subarray. Now this is a valid subarray, valid subarray, valid subarray, valid, valid, and this one is an invalid subarray. Why? Again, we can see that 1 is occurring 3 times. So this is invalid. Now this one is valid, 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 and this is invalid. Why? Because 1 is occurring 3 times. So this one is invalid. This one is valid, valid, valid. This one is invalid because 1 is occurring 3 times. This one is valid, this one is valid, this one is also valid. Okay. This is valid, and this is also valid. Now what do we want to find? We want to find their length. So let us write down the length of all these valid subarrays. So what is the length over here? Length is 1, it's 2, it's 3, it's 4, it's 5. Here the length is 1, here it's 2, here it's 3, here it's 4. The length is 1, 2, 3, 4. Here the length is 5 and here it's 6. Here the length is 1, 2, 3, 4, 5 and here it's 6. Here the length is 1, 2, 3, 4, 5. 1, 2, 3, 4. Here it's 1, here it's 2, here it's 3. Here it's 1, 2, 3. This is 1, this is 2, and this is 1. Okay. Now, what did we wanted to find? We wanted to find the longest subarray. Correct. So, what does it mean? It means that we have to find the max of these all lengths which we have written. Correct. And what is the max of these all lengths? We can clearly see that the max of these all length is 6. Correct. And which subarray is contributing to it? So, we can see that this subarray has a length of 6 and this subarray also has a length of 6. So, if we will consider 3, 3, 2, 2, 1, 1. That is, if we'll consider this subarray, we can see that all the elements in this subarray has a frequency less than equal to 2. We can see that 3 is occurring 2 times, which is less than equal to 2. 2 is occurring 2 times, which is less than equal to 2. 1 is also occurring 2 times, which is less than equal to 2. And what is the length? It's 6. Okay. Additionally, we can see that this subarray is also having a length of 6. And which is this subarray? It's 3, 2, 2, 1, 1, 3. That is this one, 3, 2, 2, 1, 1, 3. So here we can see that 3 is having a frequency of 2, which is less than equal to k. 2 is having a frequency of 2, which is less than equal to k. And 1 is also having a frequency of 2, which is less than equal to k. So we have found out our answer, which is 6. That is 6 is the longest subarray such that all the elements in that subarray has a frequency of less than equal to k. Okay. Now let us see how we can solve this problem. So since we want to find out the maximum length, right? So what we will do is we will take a variable called max length, which would be initially 0. So it will keep track of the maximum length of the subarray such that all the elements in that subarray has a frequency of less than equal to k. Okay. Now we know one thing, that is at each step we need to keep track of the frequencies of each of the elements of this nums. Correct. And in order to do so, that is in order to keep track of the frequencies, what we will do is we will make use of a hash map. So let's say that we have a hash map over here, and what we will do is we will store element and its corresponding frequency in this hash map. Okay. And we know one thing. And what is that thing? We know that what is an invalid subarray. An invalid subarray is that subarray in which frequency of any element is greater than k. Correct? Because what we want a subarray such that elements has frequency less than or equal to k. So whenever we'll get a subarray in which any of the element has a frequency greater than k, it means that it's an invalid subarray. Correct? Okay. Now let's see what we'll do. So we will take 2 pointers, release, let me represent it with R, and another pointer, current, let me represent it with C. And initially both of them will point at the 0th index. Okay. And what we will do is whenever we'll get an element, we will add it to our hash map. Correct. Now, let's see what we will do if we will hit an invalid subarray. So whenever we'll get an invalid subarray, what we'll do is we will try to make it valid. Now, how are we going to try make it valid? We'll make it valid by releasing the element present at the release pointer. That is, we will remove the element present at the release pointer. So let's say that if the name of the hash map is frequency, then what we will do is we will say frequency of nums of release minus minus. So what we have done, we have removed the element present at the release pointer and we will increment the release pointer. And until when we will do this? We will do this until the frequency of the current element doesn't becomes less than or equal to k. Okay. So till that time we will do this. So let's see what we'll do. So currently we are at the 0th index. So what we will do? We will add this element to our hash map. So we will add 1 and we will add its corresponding frequency to 1. Then we'll see that is this a valid subarray. So what is the condition for checking a valid subarray? So we will check, is the frequency of nums of current greater than k? So what is nums of current? Nums of current is 1, correct? So is the frequency of 1 greater than 1? So what is the frequency of 1? The frequency of 1 is 1. And what is k? K is 2, right? So we'll check, is this 1 greater than 2? So 1 is not greater than 2, right? So it means that we are in a valid window. So whenever we'll see that we are in a valid window, so what does it mean? It means that this could be a possible answer, right? So what we will do, we will find the max of max length, comma, current minus release plus 1, correct? What is current? Current is 0. What is release? Release is 0 plus 1. So what we'll get? We'll get 1. So what is max length? Max length is 0. What is the current length? The current length we got is 1. So what is the max of 0 and 1? The max of 0 and 1 is 1. So we will update max length with 1. Now what does this represent? This represents that we got a subarray of length 1. That is a valid subarray, correct? What does a valid subarray means? It means that all the elements in that subarray has a frequency of less than equal to 2. Now let's see which is that subarray. It's this subarray, correct? Now what we will do, we'll move our current pointer forward. So current is at the index 1. Now what we'll do, we will add this element to our hash map. So we will add 2 and its corresponding frequency as 1. Now we will check that the subarray we got up till now, is it valid? So how are we going to check? We will check that what is the frequency of 2. So the frequency of 2 is 1. So is this 1 greater than k? That is this 1 greater than 2? So this 1 is not greater than 2, correct? So what we will do, we will try to find out our max length. And what will be our max length? Our max length will be max of max length, comma, current minus release plus 1. So what is max length? Our current max length is 1, correct? And what is current minus release plus 1? So current is at 1th index. So we will say 1 minus release it as 0th index. So 0 plus 1. So what we'll get? We'll get 2. So what is the max of 1, comma 2? So the max of 1 and 2 is 2. So we will update our max length to 2. And what does this 2 represent? This 2 represent that we have got a subarray of length 2 such that all the elements in it has a frequency of less than equal to k. Let's see which is that subarray. It's this subarray, correct? That is this 1 and 2. So we can see that 1 and 2 both are having a frequency less than equal to this k, correct? Now what we will do, we will move our current pointer forward. So our current pointer will reach to the second index. Now what we will do, we will add this element 3 to our hash map. So we'll have 3 and its corresponding frequency as 1. Now we will check that the subarray we have got up till now, is it valid? So how are we going to check that? We will check that what is the frequency of 3. So the frequency of 3 is 1. Is the frequency of 3 greater than 2? So frequency of 3 is not greater than 2, correct? So what we will do, since we have got a valid window, so we will find out current minus release plus 1. So what is current? Current is 2. What is release? Release is 0 plus 1. It will give us 3. So what would be the max of max length? That is 2, comma, the current length, that is 3. So it would be 3, right? So we will update our max length to 3. So what does it mean? It means that we have got a subarray of length 3. That is a valid subarray. That means that all the elements in it has a frequency of less than equal to 2. And what is that subarray? It's this one, correct? We can see that all the elements in this subarray has a frequency of less than equal to 2, correct? Now what we will do, we'll move our current pointer forward. So our current pointer will now point at the third index. So we have a 3. So what we'll do, we will increment the frequency of 3. Now we will check whether this window is valid or not. And how are we going to check? We'll check the frequency of nums of current. What is nums of current? Nums of current is 3. What is frequency of 3? Frequency of 3 is 2. So is this 2 greater than 2? So 2 is not greater than 2. So what does it mean? It means that we are in a valid window. So again we'll find current minus release plus 1. So current is 3 minus release is 0 plus 1. So it will give us 4. So what would be the max of max length, comma, current minus release plus 1? So max length is 3, comma, 3 plus 1 will be 4. So the max length will get updated to 4. Okay. And what does it mean? It means that we have got a subarray of length 4 such that all elements in it has a frequency of less than equal to k. Correct. And this is that subarray. Now what we will do? We'll move the current pointer forward. So the current pointer will now reach to the fourth index. Now what we will do, since we got 2, so we will increment the frequency of 2. Now we will check, is this window valid? So we will see that the frequency of 2 is 2. Is this 2 greater than 2? So 2 is not greater than 2. So what does it mean? It means that this window is valid. So what we'll do, we'll find current minus release plus 1. So what we'll get? We'll get 5. So what we'll find? We'll now find the max of max length, comma 5. So what would be the max? The max would be 5. So max length will get updated to 5. It means that this is the subarray of length 5 such that all the elements in it has a frequency of less than equal to k. Correct? Now what we will do? Now we will move our current pointer forward. So our current pointer will reach to the fifth index, and since we got a 2, we will increment the frequency of 2. Now we will check whether this window is valid or not. So what we'll do? We'll check that what is the frequency of 2. The frequency of 2 is 3. So is this 3 greater than 2? So we can clearly see that 3 is greater than 2. Correct? So it means that we are in an invalid window. Correct? And we can clearly see that if we have this as our subarray, then this is an invalid window. Why? You can clearly see that 2 is occurring 3 times, right? And what do we want? We want an subarray such that all the elements occur either 2 times or less than 2 times, right? So this is an invalid subarray. So what we'll do, we will try to make this window valid. And how are we going to do that? We are going to do that by removing the element present at our release pointer. So what we will do? What is the element present at our release pointer? It's 1. So what we'll do? We will release it. And how are we going to release it? We are going to release it by decrementing its frequency. So the frequency of 1 will become 0 and we will increment our release pointer. So the release pointer is at 2. Now we will again check that is the frequency of 2 greater than k. So what is the frequency of 2? The frequency of 2 is still 3 and 3 is greater than 2. So it means we are still in an invalid window. So what we'll do? We will remove the element present at the release pointer. So what we'll do? The element present at the release pointer is 2. So we will decrement its frequency. So the frequency will become 2 and we will move the release pointer forward. Now again we'll check that what is the frequency of 2. The frequency of 2 is now 2. So is this 2 greater than 2? So 2 is not greater than 2. So what does it mean? It means that now we are in a valid window. Okay. So since we are in the valid window, so what we'll do? We'll find current minus release plus 1. So where is current? Current is at fifth index. What is release? Release is 2 plus 1. So what we will get? We'll get 4 from here. Correct. Now what is the max of max length? And this 4. So the max will be 5 only. So it will remain as it is. Now what we will do? We will move our current pointer forward. So our current pointer is now pointing at the index 6. So what we'll do? We will increment the frequency of this 1. So we'll get a 1 over here. Correct? Now we will check, is this a valid window? So what is the frequency of 1? The frequency of 1 is 1. So is this 1 greater than 2? So 1 is not greater than 2. So what does it mean? It means that we are in a valid window. So what we'll do? We will find out current, that is 6. Let me write it over here. Minus release. What is release? Release is 2 plus 1. So what we'll get? We will again get 5. Now what we'll do? We'll find the max of max length and the current length. So what would be max of 5? 5. The max would be 5 only. So max length will remain as it is. Now what we will do? We will move our current pointer forward. So what we have got? We have got a 1. So what we will do is we will increment the frequency of this 1 to 2. Now we will again check whether this window is valid or not. And how are we going to do that? We are going to check that what is the frequency of 1. So we can see that the frequency of 1 is 2, which is not greater than this 2. Correct? So it means that we are in a valid window. So what we will do? We will find out current minus release plus 1. And what we will get? We'll get 6. Now what we'll do is we'll find the max of max length, that is 5, and the current length, that is 6. So what would be the max of 5 and 6? The max would be 6. Correct? So what will happen is this max length will get updated to 6. And what does it mean? It means that we have got a subarray that has 6 elements such that all the elements in it has a frequency of less than equal to k. And which is that subarray? That subarray starts from this release pointer to this current pointer. And we can clearly see that we have 2 3s, that is its frequency is less than equal to 2. We have 2 2s, that is its frequency is less than equal to 2. And the frequency of 1 is also less than equal to 2. So we can clearly see that we have got a subarray that has elements in it. And what is that subarray? Let's write it down over here. We have 3 3 2 2 1 1. Correct? Now what we will do? We'll move our current pointer forward. So current pointer will point at the 8th index. Since we have 3 present over here, so what we'll do? We will increment the frequency of 3. Now we'll check whether this window is valid or not. So what is the frequency of 3? The frequency of 3 is 3. Correct? So is this 3 greater than 2? So we can clearly see that 3 is greater than 2. So what does it mean? It means that we are in an invalid window, and we can clearly see that if we have this subarray, then we can see that 3 is occurring 3 times, right? But what do we want? We want all the elements to occur either 2 times or less than 2 times, correct? So since we are an invalid window, we will try to make it valid. And how are we going to do that? We are going to remove the element present at the release pointer, correct? So what we will do, we will decrement the frequency of 3 because 3 is present at the release pointer, right? So the frequency of 3 will become 2 and we will increment this release pointer. Now we will again check whether this window is valid or not. So what is the frequency of 3 now? The frequency of 3 is 2. So we will check, is this 2 greater than 2? So 2 is not greater than 2. So what does it mean? It means we are in a valid window. So what we'll do, we will find out current minus release. Release is 3 plus 1, correct? So what we'll get 6. Now what we'll do, we'll find out the max of 6, 6 and what we'll get 6 only. So the max length will remain as it is. And what does it mean? It means that we have got a subarray of length 6 such that all the elements in it are occurring either 2 times or less than 2 times. And we can clearly see that this is that subarray, correct? Let's write it down over here. 3, 2, 2, 1, 1, 3, correct? Now we will move our current pointer forward. So our current pointer will now point at the 9th index. So we have a 1, so we will increment the frequency of 1, 2, 3. Now what we will do, we'll check whether this window is valid or not. Okay. So what we'll check is, what is the frequency of 1? The frequency of 1 is 3. So is this 3 greater than 2? So 3 is greater than 2. So what we'll do, we will try to make this window valid. So how are we going to do that? We are first going to remove the element present at the release pointer. And what is the element? It's 3. So what we will do, we will decrement the frequency of 3. So it will become 1 and we will increment the release pointer. So release pointer will now point over here. Now we'll again check whether this is a valid window or not. So we'll check that what is the frequency of 1. Okay, that is what is the frequency of the element present at the current index. It's 3, right? So is this 3 greater than 2? So 3 is still greater than 2. So what we'll do, we'll again release the element. So what is the element present at the release pointer? It's 2. So what we'll do, we'll decrement its frequency to 1 and we'll increment the release pointer. So the release pointer will point over here. Now we will again check that what is the frequency of element present at the current pointer. So the element present at the current pointer is 1 and its frequency is 3. So is this 3 greater than 2? So we can see that 3 is greater than 2. It means it's still an invalid window. So what we'll do is we will release the element. So the element is 2. So what we'll do, we will decrement its frequency. So the frequency of 2 will become 0 and we will increment the release pointer. So the release pointer will now point over here. Now we'll check that is our window valid? So we can see that the frequency of 1 is still 3, which is greater than 2. So it means that our window is still invalid, correct? And we can clearly see that if this is our window that is starting from release up to current, so we can see that 1 is occurring 3 times, right? So it's still invalid. So what we'll do, we will again remove the element present at the release pointer. And what is the element present at release pointer? It's 1, right? So what we'll do is we'll decrement the frequency of 1, so it will become 2 and we will increment the release pointer. So now we'll check that what is the frequency of element present at the current pointer. It's 2. So is this 2 greater than 2? So 2 is not greater than 2. So what does it mean? It means that now we are in a valid window. So since we are in a valid window, what we'll do, we'll find current, that is 9, minus release, that is 7, plus 1. So what we'll get? We'll get 3. And now what we'll do, we'll find the max of 6 and 3. So what would be the max of 6 and 3? It would be 6 only, correct? So what we'll do, we'll simply now move our current pointer forward. So you can see that now our current pointer is pointing at the 10th index, which doesn't exist. So what does it mean? It means that we have successfully processed all the elements of nums and we have got our answer. And what is the answer? The answer is 6. That is, we have got the subarray that has a length of 6 such that all the elements in it are occurring either 2 times or less than 2 times. And which are those subarray? It could be either this subarray or this subarray, correct? Because both of them are having 6 elements and all the elements are having a frequency of less than equal to 2, correct? Now I hope it's clear to you all. So let's quickly code this. So we will start on by taking a variable max length, which would be initially 0, and it will keep track of the maximum length of the subarray that has at most k frequency, that is in which all the elements has a frequency of less than equal to k, okay? Then we'll take our release pointer and initially it will point at the 0th index. After that, we have to create a hash map, that is we'll take an unordered map of type int, int. Let's call it as frequency. And what we will store is, we'll store the element and its corresponding frequency in it, correct? Because we need to keep track of the frequencies of the element, right? In order to solve this problem. Now what we will do, we will iterate over all the elements. So current equals to 0, current less than nums.size, current plus plus. And after that, what we'll do, after that, we'll add the current element to our hash map, correct? So we will say that frequency of nums of current plus plus, that is add the element present at our current pointer to the hash map, correct? Now, after that, what we'll check is, after that, we'll check for the invalid window. And when is a window called invalid? It is called invalid if the frequency of the element present at the current pointer becomes greater than k. Correct? Now, if we get an invalid window, then what we'll do? We will try to make it valid. And how are we going to make it valid? We will remove the element present at the release pointer. Correct? And after that, what we'll do? We will increment the release pointer. Fine. And until when we will do it until we don't get that the frequency of the element present at the current pointer becomes either less than or equal to k. Until that time, we'll keep on doing this. Okay. And we have to add one more check over here. That is, our release pointer should be less than or equal to current pointer. Correct? Now, if we come out of this while loop, or if we don't go inside this while loop, then what does it mean? It means that we are in a valid window. And what does it mean? It means that we have got a subarray such that all the elements in that subarray are occurring either k times or less than k times. Correct? So that time what we'll do, we'll find the current length. Correct? And what is current length? How are we going to find the current length? We are going to find the current length by saying that current minus release plus 1. Correct? So what we'll do is we'll say current minus release plus 1. So it will give us the current length of the subarray. Now what we'll do, we'll find the max length. And what would be max length? Max length would be the max of max length and the current length. Correct? Now finally what we'll do? Finally we'll return this max length. Now let's quickly run this. So it's giving us a correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we consider that there are n elements present in nums, then the time complexity would be order of n. Why? Because we can see clearly over here that what we are doing, we are iterating over all the n elements present in our nums, right? In order to find the longest subarray. So since we will be iterating over all the n elements, therefore the time complexity is order of n. And the space complexity is order of n as well. Why? Because we are using a hash map, correct? And in the worst case, what could be possible? In the worst case, the value of k could be 1 and all the elements that we can have can exist 1 times, correct? So when we'll have distinct element, then what we'll have? We'll have a space complexity of n because we'll have all the n entries present in our hash map, correct? So that's all about today's daily LeetCode challenge. Thank you.